Optimality. Here's our graph that we drew. Our x-axis represents good number 1, and our y-axis represents good number 2 here. The green line is our budget line, and a budget line is the combo of goods that has the same amount of spending. And our red line here is our indifference curve, which is the combo of goods that results in the same total utility. The optimal point that we're trying to get to, though, is represented here, the blue point, as point X.
Yeah.
So right here we have a representation of a budget line. And what a budget line is it's a line that shows the amount of money that you have to spend on a certain thing. Here we call them goods. So this entire line represents the same amount of money. And the two intercepts, the way that you understand them is if you put all of your money into one particular good. For example, the vertical intercept is if you were to put all of your money into good number 2, you would get 5, but you would get 0 of good number 1. And the intercept on the horizontal axis is the exact opposite. If you were to put all of your money that you have budgeted into good number 1, you would, on this graph, get 5 of those and 0 of good 2. And here we have it in equation form, represented by, for the horizontal axis, we have the total budget over the price of good 1. And then for the vertical axis, we have the total budget over the price of good 2. And so that's basically how to understand
Just
a budget
to explain
line.
a movement around along budget curves, but along the budget line, like a shift from S to D. Here, the utility would rise because you're going from curve C to curve E, still staying on your budget line, so you're still spending all your money. You're just gaining utility, in this case, off curve E for good 1. On the indifference curve, how V, W, and X are all on the same curve, but points V and W are over the budget line right here, which means these points are impossible to reach because your budget line is your constraint and you can't go above it. So going on to curve, or to point X right here, this would be your optimal point of utility because it's the furthest curve outwards, but still staying on your budget line, so it's maximizing your amount of money spent as well as your utility.
So, point X. Point X represents the point on our two curves where the indifference curve is tangent to the budget line. This means that the trade-off of goods to maintain a certain level of utility is equal to the trade-off of goods to maintain a certain level of spending that you have, which is your budget constraint. So our budget line, as you can clearly see, the slope of the budget line is -1, which means that if I chose to reallocate my money from one good to another, if I chose to spend an additional $1 on good 1, I would have to spend $1 less on good 2, and vice versa. This same kind of concept is represented on the indifference curve as the marginal rate of substitution, which is similar to this, talks about the slope of the line in a certain area, but at point X, that slope is the same as the budget line, which is kind of the definition of tangent. So that slope here at point X is also -1. So, which means that in order to get the same amount of utility, if I were to reallocate, if I were to have an additional, consume an additional good 1, I would have to consume 1 less of good number 2. And so that's why point X is what maximizes our utility.
Although, for those of you who have not taken AGB 212 yet, this may seem awfully confusing. However, let me make it simpler for you. Okay, so right here we're going to have days of skiing. And right here on the x-axis we will have days of horseback riding. So, right here represents the days of skiing that we can do per month, and right here this represents the days of horseback riding we can do per month. So, we were given a budget of $50. So each day of skiing represents or costs $10, and then each day of horseback riding costs $10. So if you were to spend all of your money on days of skiing, you would be able to purchase 5 days worth for $50. So if you take this point here and then you do the same thing with days of horseback riding, you spend all of your budget on days of horseback riding, which would be 5 days or $50. You draw a point here as well, and then you connect those two lines, and then so for each of the combinations on here, you would get the same amount within your budget. So you'd get 4 days of skiing with 1 day of horseback riding, and so on from there. And then, okay, that's all I need. The indifference curve, which I'm about to draw, represents your amount of good feeling that you get from all the possible different combinations of days of skiing and days of horseback riding. So, while drawing the indifference curve, it intersects our budget line at exactly 1 point right here. And at this 1 point, our happiness or good feeling is maximized while staying within our budget. So this is the best possible choice.
In terms like days of skiing and horseback riding on the indifference curve, we can see here on point S, you'd have 5 days of skiing while having 1 day of horseback riding. And this would, on the indifference curve, have a curve C. But a movement along the budget line to point D, where you have 3.5 days of skiing and about 3 days of horseback riding, would increase your utility while moving indifference curves to curve from C to E, and then a shift, and that would be on the budget line. So there you would be spending the same amount of resources as S, just gaining the movement from V, W to X. V and W would have 5 days of skiing, or V would, and W would have 4 days while having about 3 days of horseback riding. But these points again are above the budget line, so with the constraint of your budget right here, $50 at the price, these points are impossible to get, and that's way too much. So the shift would be down to point X right here on the curve, indifference curve A, with about 2 days of skiing, 3.5 days of horseback riding, and this would be your optimal utility, and you gain the most fun.